my name is Luh Suwandewi Utami Nesa. Today I will try to explain a little bit about quadratic function. Before that, may I apologize because I know there's still a lot of wrong pronunciation. Thank you for watching our video. Please enjoy our video. Okay all, do you remember when we studied algebra? On that section, we have learned about linear equation and function. After we learn linear equation, we will know that linear equation graph is a straight line. And what do you think about quadratic equation and function? So today, we will learn about quadratic function. Quadratic function is a function that can be described by the following form. Y equals ax squared plus bx plus c. A and b are coefficient and c is constant. So the one factor that identifies this expression is quadratic is exponent 2. The first term is always be ax squared and a is not equal to 0. As we know, the linear equation graph is a straight line. This is the picture of linear equation graph. And then, what do you think about quadratic function graph? This is the picture. The quadratic function graph is look like U. So, do one other way to refer to the graph that represents a quadratic function is the parabola. The parabola can be pointing up or down, and it can be either wider or narrower. It doesn't have to start right at the origin, so it can be starting anywhere else as well. As we mentioned before, that the parabola does not necessarily have to be on the origin. So the vertex is the point in the parabola where the curve changes directions. This is the picture when the parabola is opening up. So the vertex is the minimum point or the lowest point on the graph. The second is the picture if the parabola is opening down. So the vertex is the maximum point or the highest point on the graph. From this picture also, we can notice that the parabola is symmetrical to itself. If the vertex is a minimum, the range is all real numbers greater than or equal to the y value. If the vertex is maximum, the range is all real numbers less than or equal to the y value. And then we will learn the type of quadratic function. There is some type of quadratic functions, such as number 1, y equals ax squared plus bx plus c, and then if a equals to 1 and both of b and c equals to 0, so the quadratic function formula has changed to y equals ax squared. It makes graph that have axis of symmetry on x equals 0 and have the vertex point on 0, 0. There is the picture. Number 2, y equals ax squared plus bx plus c, and then if b equals to 0, so the quadratic function formula has changed to y equals ax squared plus c. It makes graph that have axis of symmetry on x equals to 0 and have the vertex point on 0, c. You can see it in the picture number 2. Number 3, y equals ax squared plus bx plus c, and then if the vertex is h and k, so the quadratic function formula have changed to y equals a multiplied x minus h squared plus k. Okay, that's all from me. Thank you for your attention. The presentation will be continued by my friend Hani.
Well, hello everyone. Let me introduce myself. My name is Luh Hanny Arsana Putri. The last 3 digits of my student identification number is 057. So before, my partner already explaining about what is quadratic function, whether it's about the definition, and then about the graph of quadratic functions, and also the vertex of quadratic function. So this time I will explain about the axis of symmetry, discriminant, and how to do the graph of the quadratic functions. So please check it out. So let's just start with the first explanation about the axis of symmetry. The axis of symmetry of a parabole is the vertical line through the vertex. An axis of symmetry, also known as a line of symmetry, that will divide the parabole into a mirror image. Now you guys need to know that the line of symmetry is always a vertical line. Let me repeat it once more. The line of symmetry is always a vertical line of the form x equals to n, where n is a real number and its axis of symmetry is the vertical line x equals to 0. For a parabole in standard form, that's y equals to ax squared plus bx plus c, the axis of symmetry has the equation x equals to negative b divided by 2a. You need to note that x equals to negative b divided by 2a is also the x-coordinate of the vertex of the parabole. Let me show you for some example. Here I have a sample that find the axis of symmetry of the equation y equals to 2x squared plus x minus 1. That's the example. Now we have to determine that the equation has an a equals to 2 and b equals to 1. So the input the value of a and b into the formula of x equals to negative b divided 2a. Then we get that the axis of symmetry of the vertical line is x equals to negative 1 divided by 4. So that's about the axis of symmetry. Now we're going to the discriminant. In this quadratic function, there's a term that called as discriminant. It's symboled as d, and it's capitalized. Its form is d equals to b squared minus 4ac. Well, you guys need to know that there are 3 types of discriminants, such as if d greater than 0, then the quadratic function has 2 different roots. Underline it, 2 different roots, and intersecting in 2 different spots. You can see in the graphic on the red lines, that's the graph if the d greater than 0. Then we have the second type of discriminant, that is if d equals to 0, then the quadratic function has 2 identical roots. Remember, 2 identical roots. That's why the curve will only intercept one spot on the x-axis. In the picture you can see the green one, the green line that represent if the d equals to 0. And next you have to see the blue line on the picture. that shows the curve, if the d less than 0, the curve will never even touch the x-axis, and not even for once. So that's about discriminant. Now we're going to how to do the graph of the quadratic function. Now I already have an example for the quadratic function, that y equals to x squared minus 4x plus 1. And what we need to do when we want to make a graph of quadratic function is, the first step, determine which form of quadratic function that you have. In this example, I have the standard form, as you guys can see. And then the second step is define your variables. In the example that I show you guys, we can see that the a of the function is 1, and then b equals to -4, and c equals to 1. And then after that, we move to the third step. We need to calculate the axis of symmetry using the formula x equals to -b divided by 2a. And then we just need to input the value of the a and b as we need, and then we get that the x equals to 2. And then after we get the calculation of the axis of symmetry, now we are going to move to the fourth step. It's about define the coordinate spot. Here you can find the intercepts in both axes, whether it on the x-axis and the y-axis. And in this example, I can find that the intercept is on 0.1, and then 0.27.0, and the last spot is on 3.73.0. And after that, we are going to the last step. We just need to plot the vertex, and here I'm using GeoGebra for give an illustration about the graph of the function. And as you can see on your screen, that the graph is opening up when its vertex on the axis is 0.1, and as I said before, right? And then you already get the graph of the function, that y equals to x squared minus 4x plus 1. And that will be the last topic on this video. Okay, that's all my explanation about the axis of symmetry, discriminant, and how to do the graph of quadratic functions. So that's all for today. Thank you for watching, and see you.